Let's. Oh, I wanted to do some examples with the power functions. Okay. I had a few students that were still having a little bit of trouble with this, and it's okay because these are not the easiest things in the world. Power functions, and most of the functions here, most of the problems were of a specific kind. Okay. The domain when we had division. Okay, let me explain the division here. It's when we have division, like find the h of n over the g of n, you have to have what's called a domain restriction because in any fraction, you cannot have 0 in the denominator. So g of n cannot equal 0. So that's always going to be a domain restriction for a fraction. So let's go ahead and do this problem. So it says find the h of n. So the h of n is 2n squared minus 4, and that's going to be divided by the g of n, which is 4n minus 1. Now, a lot of times, the answers in the like delta math or something, it'll be simplified. Okay, so they're going to want you to simplify it if you can. So I notice here that I can take out a 2 from the top. So I have 2, and I end up with n squared minus 2 all over 4n minus 1. Now, you got to be careful because in delta math, they may require you to simplify it, or it may accept this one. Now, we can't go any further as far as simplifying. This does not factor any further. But this does have a domain restriction because it has a denominator. In other words, 4n minus 1 cannot equal 0. Okay, so we're going to find out what when it does equal 0, what value of n makes this equal to 0. And then we'll put that as an exception for our domain. So I'm going to go ahead, add 1 to both sides. So I get 4n equals 1, then divide both sides by 4. So n here cannot equal 1/4. So the way I can write this is my domain restrictions is all real numbers except n equal 1/4. Now there's a couple of different ways you can write that. Another way to say all real numbers is a double bar R. That means all real numbers except x, or n in this case, cannot equal 1/4. So this is really a kind of a shortcut version of it. Okay. So again, that's with fractions. Got to have a domain restriction. Now, another problem that students were having trouble with is what was called composite functions. Okay, with composite functions, what you have to do here is this is the f of g. Now this time it doesn't have an n like we had an n up here. They actually give us a value for n, so we have to figure out what that value is. The first thing we do is start with the innermost parentheses. So first thing we have to do is find the g of 7. And remember, it's just function notation. So wherever we see an n, we're going to replace it with 7. Okay. So if I'm looking at the g function, because that's g, I need 7. I'm going to replace, for that n, minus 3. And 7 minus 3 is 4. So I'm going to take this 4, replace the g of 7 with that. So I end up with the f of, and this time I'm going to put 4 in there for the g of 7. And now all I have to do is figure out what the f of 4 is. And again, I'm going to replace it, n, with 4. So I have 4 squared. Use parentheses, especially when you have an exponent. So I have 4 squared minus 5. That equals 16. 4 squared is 16 minus 5, which is 11. Okay. Now, I'm good if you just put 11, but again, technically, delta math might, require the whole thing, where if you say the f of g of 7 equals 11, I think if you just put 11 in there, it'll be fine. I'm okay if you just circle 11, but realize that this is the technical answer. Okay? Any questions on the power functions section? Okay. Then you guys did evaluating graphing polynomials. Now, this 5.1 was actually pretty easy if you watched the video, because it's all about terminology. Okay? First of all, standard form is y equals ax squared plus bx plus c for quadratics. But what it really means is from highest exponent to lowest exponent. So if I had of x to the 5th, then it would be x to the 4th, x to the 3rd. That's standard form. Now, the degree is the sum. The degree of your polynomial is the sum of all the highest. I shouldn't say highest. It's the sum of the exponents of the variables. And I don't think they threw too many tricks in here. I think they kind of kept it simple, where they just had one variable, so you didn't have to add up the exponents on the different variables. Like looking at number 2, my highest exponent is 4, and I only have the one variable, so it kept it pretty simple. Okay, so and I'll go ahead and do 2 in a sec. Okay, so the name and type, there's a chart in your notes. You look at the exponent. If it's a 4th degree, then it's a quartic. If it's 5th degree, it's quintic. If it's 2nd degree, it's quadratic. 1st degree is linear, so on and so forth. It's in your chart. Okay, so look at your degree of the polynomial, and it's on the chart. Degree of polynomial. Degree of the polynomial on the chart. Okay, and then the lead coefficient. Okay, the lead coefficient is that. Now, the coefficient is the number being multiplied to the variable. So the lead coefficient, now first put it in standard form so that you don't mess up on the lead coefficient. In this one, let's go ahead and do number 2. So if I were to put this in standard form, put the highest degree first, I got a plus 4v to the 4th I don't have a cube, but I do have a squared. Take the sign with it, okay, guys? Minus 10v squared plus 2v, and then my constant plus 2. So I put it in standard form. What's my degree? It's fourth degree, or more explicit, it's a quartic. Okay, that's the name type. So fourth degree name type is quartic, and then the lead coefficient, and we just put LC, is that number being multiplied to the variable, the first one. So lead coefficient is 4. Questions on that? Now, as far as sketching it, the best thing to do here, put it in your calculator. Okay, this is a quadratic, so it's some type of parabola. Okay, where it's up 11. Now I'm all the way up here at 11, and I know that it opens up somehow. So if I were to put that in calculator, I'd have something else, a little more accurate. But the domain and range, don't forget, for all parabolas in this course, domain is negative infinity, positive infinity. Of course, it has parentheses because we can never reach it. Now, the range is going to be that vertex, the y value of the vertex. So in this case, it's our constant c. So it's going to go from 11, includes that 11. So I'm going to use a bracket. And then it goes up to infinity. So that's what you were supposed to do with these. Just sketch a real rough graph, put it in a calculator and get your rough draft, and then come up with domain and range. Let's see if there was anything else that students were having. And behavior. Whenever you see and behavior, remember, go ahead and write that template. Now, I think we did this in term 3. And behavior. As x approaches blank, right, the f of x or y approaches blank. So go ahead and write that template down if it's not there for you. And if you remember, we always start out as x goes to the left. I'll use a different color. Negative infinity. Usually these are filled in. Okay, so go ahead and put that in your calculator. Again, it's going to be a parabola up here at 15, something like that. So as x goes to negative infinity, so here's my x, start at the origin. As it goes to negative infinity, my y here goes to positive infinity. And as x goes to positive infinity, or to the right, again, my y goes to positive infinity. What if you don't have, you should have a TI emulator on your Chromebook. Okay. Let's do another one of these. Let's do number 9. Okay, number 9's graph. It's going to be one of these. Well, let's see. I've got a negative x to the 5th, so it's probably going to be something like this. I think I might have one too many bumps in there. Let's double check this. I think I do have one too many bumps. So negative x raised to the fifth negative x raised to the fifth plus 3x cubed. Graph it. That was pretty close. No, I was actually closer than I thought. Okay, so again, domain, or I'm sorry, we're doing end behavior. So I should have wrote down f of x approaches blank as x goes to the right, or I'm sorry, goes to the left, negative infinity. And the f of x approaches blank as x approaches positive infinity or goes to the right. Okay, so as x goes to the left or negative infinity, my y is going to positive infinity. And as my x goes to positive infinity, my y is going to negative infinity. Okay? Yeah, that gets a little tricky, but just gotta remember to x value what's happening to your graph. Where's it ending up? All right, evaluate, you guys know how to do. Okay, again, it says m equals -5. I highly suggest recopying this with parentheses. M squared plus 15m plus 22. Okay, because if you don't put parentheses, guess what's going to happen in your calculators? You're gonna get the wrong answer because you're gonna, if you don't put parentheses, 5 cubed is going to come out probably positive. -5 is going to come out negative. So make sure you put the parentheses in there. You guys can figure that out. Advanced factoring. All kinds of problems here. And again, it's from, it would, not from, if you have one of those flow charts from way back when we've done factoring like a couple times now. And I don't, like I said, I gave mine away, so I'll have to find another one to print out. I will put it on Google Classroom. What it tells you here, okay? Even tells you, take out the common terms first. So what you're doing is, you're looking at 50 and 18. So if I look at the factors of 50, I got 1 times 50, 2 times 25, 5 times 10. And then I'm looking at 18. Let's see, 1 times 18, 2 times 9, and then 3 times 6. I look at your factors here, and I have to pick out the highest one. Let's see, this one's got 2. Looks like I can only take out a 2. Okay, so I'm going to take out a 2. And I'm going to see if I got hang on a sec, guys. I'm going to see if I got one of those flow charts. Okay. It would be really helpful if you have one of these flow charts, if you still got them from last term. Flow chart. There it is. I got to go ahead and print it out. Okay, this is what that flow chart looked like from last semester. And like I said, I will put it on Google Classroom. Anyway, so I'm taking out a 2. And then I look at the P, in this case, P's. And I can't take out any P's because this one doesn't have a P. So I'm left with 50 divided by 2 is 25. P squared. 18 divided by 2 is 9. Now, I'm not done. Okay, so I factored out the common terms. And then I got to keep going here and make sure I can't factor it out any further. What type of polynomial do I have? Do I have 2 terms, 3 terms, or 4 terms? Well, this one, I'm ignoring that 2 because it's just a factor. So I have 25, so that's 2 terms. Okay. Now, I don't know if it's a difference of squares or not. And I know it's difference because it's subtraction. But I'm going to go ahead and look down here at my perfect squares. And notice that 25, 9, and 25 are perfect squares. Okay. 25 is, let's see, 1, 2, 3, 4, 5 squared. So I'm going to rewrite this as 2 times 5 squared, P squared, and 9 is 1, 2, 3 squared. I'm going to rewrite this as 3 squared. So this is a difference of squares. Now, my A, and be careful with this, are the bases of what's being squared. It's not 5 squared. My base is 5P. Okay. My B, it's the 3 being squared. So when I look at the formula here, I have my A, difference of squares. This factors to A plus B, A minus B. So A plus B and A minus B. And don't forget, bring that factor down. It does get quite a bit more complicated, okay? For example, let's look at number 4 here. Okay, the first thing you're going to do is factor out any common terms. If I'm looking at 36 and 100, well, let's see. For 36, I might even have to do this one. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, 100, 1 and 100, 2 and 50, 3 doesn't work, 4, and let's see, 25, right? 4 quarters in the dollar. 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 and 1 10 does. 10 times 10. So let's look at these factors here. What do we got? 4? 4 is the only one, right? It's the highest. So I'm going to take out a 4. And I got 9b to the 4th minus 25. And again, 9 and 25, we know they're perfect squares. So we have a difference of squares. So my A is going to be, now be careful. Let's rewrite this. I have 4 times 3 squared. Now, b to the 4th I can write as a square. B squared being squared minus 5 squared. B squared is b to the 4th. So my A is the base. 3, be careful, this is my base here. That's what's being squared. B squared. And then my B, oops, my B's equal to 5. So I have A plus, geez, I'm going to make a lot of B squared is my A, 3B squared, minus or plus, whatever one you want to put first, B, and A minus B. And don't forget to bring down that 4. Okay. Sum of cubes, it even tells you what it is. So if you go to 2 terms, right, it's binomial, sum of cubes is right here. And I know 27 was cubed because I looked, it's got perfect cubes right here. It's 3 cubed. So my A is M, B is the base 3 being cubed, and the formula, sum of cubes, A plus B times A squared, M squared, minus A times B, minus A times B. I'm going to put the 3 first. Plus B squared. B squared, 3 squared is 9. Okay. One more I want to show you, because this one you may not remember. Factor by grouping. Come on, focus. So I'm looking at 4 terms. Okay, it says factor by grouping. Group the first 2 terms and group the second 2 terms. Now I just take out common factors. 15 and 18, I can take out a 3. This one has 3 x's. This one has 2 x's, so I can take out 2 x's. 15 divided by 3 is 5. 3 x's divided by 2 x's gives me 1 x. Minus 18 divided by 3, 6. And taking both those x's out. This is a positive. I'm going to put a plus here. 35 and 42, I can take out a 7. There's no x there, so I'm not taking on any x's. 35 divided by 7, 5x. 42 divided by 7, 6. The whole idea here is to get that common factor out. And you put 5x minus 6. What I have left over, 3x squared plus 7. And there's your answer. And I know it's your lunchtime. So adios, guys, in class. All right, guys. That's what I have for you. And I'll post this up on the Google Classroom. Got any questions? Please feel free to hang around.